Now here we are at experiment 2, Introduction to the Stimulus-Response Relationship, and on this page there's just a series of questions for you to work through, so I'm going to leave those to you. And then if we flick over to the next page, we see the experimental portion of this activity, which is measuring the stimulus-response relationship. Now what we mean by the stimulus-response relationship is that as we change the stimulus strength, so dial up different voltages that we're applying to the nerve, we will get different responses. So the response that we get from the nerve will also change. And so this activity is about examining what the relationship is between the stimulus strength and the response that we get out of the nerve. So if we scroll down to the methods section, we see that it says, to calibrate your scaling, start by stimulating the nerve with 1 volt. Now the reason for that is that we don't know how big our responses are going to be, and so we want to stimulate the nerve with a reasonably large voltage so that we can get a reasonably large compound action potential, and we know what we need to set our y-axis to. So let's do that first of all. You can adjust any of the responses to make them easier to view, and then we need to label each of our responses. Now we had a look at how to add labels in the technical video, but briefly just use the comments box down here to type in what the stimulus was used for each response. We'll be harvesting the response amplitude as we go, but if you ever need to go back and remeasure something, then it's a good idea to have all of your traces labeled. Now having labeled this response, we'll also measure it. Now we also discussed this in the technical video, but again just to demonstrate what we're doing, we grab the marker and drag that down to the baseline. We then put a pointer over the amplitude, over the peak of the response, and then drag the response amplitude value down into the table. Now next we want to measure at least a couple of sub-threshold stimuli, that is stimuli that are so small that they don't actually elicit a response. We don't necessarily want to go to 0, because then we're not delivering a stimulus at all. Instead, let's try 0.05 volts. We'll click Start. Then we'll label that response. And then measure the size of the response. For sub-threshold stimuli, you won't be able to see a response, and for very small sub-threshold stimuli, you probably won't even see much of a stimulus artifact. And so to see where to add your marker, you can just use the dimmed trace from the previous page. So if we drag our marker down to here, and our pointer over to here, and we can see where to put our pointer because of the maximum on a previous page, and we can then just drag our response down into the table. Right, and so then we'll keep going, and we'll keep increasing the stimulus strength until we get a response. So here we can see at 0.2 volts, we didn't really get a response, but then at 0.25 we did. Now the response at 0.25 was relatively large, and so the actual threshold was probably a little bit between that. So between 0.2 and 0.25 volts was where we're getting our actual threshold. And so if you ever want to go back to deliver different stimuli or some additional stimuli, then you can do that. And so that's what we do here. So we try a couple more additional intermediate values, and we can see that we're starting to get a response at around 0.21. So that's probably our threshold, and then we just keep going on from there. Now up the top end of the stimulus-response relationship, you'll notice that as you keep increasing your stimulus strength, the response amplitude will keep getting bigger. But then eventually you'll reach the point where you've actually recruited all of the axons in your nerve. And so even if you keep increasing the stimulus strength, you're not going to see any additional increase in response amplitude. And that's the point that we're trying to look out for here. Now in this example, you can see that at 0.6 volts, we got an amplitude of 1.72 millivolts. But then as we increased the stimulus to 0.7, then 0.8 volts, we didn't really get an increase in response after that. And so 0.6 for us was our maximum stimulus that produced the maximum response amplitude. Now you want to make sure that you've measured at least a couple of suprathreshold stimuli, which we have. And then the instructions say to plot our data. Now we'll be doing this for each of the data that we collect from each of the experiments, and I'll leave that for you to do. But because this is the first one, we'll go through this in a little bit more detail this time. First of all, highlight the data and copy it across into Excel. Make sure you've labeled each of the columns. And then I find the best type of plot to use for this type of data is a scatter plot, since both our values, the stimulus strength and the response amplitude, can be pretty much any value. And you can choose either a scatter plot with no connected lines or a scatter plot with connected lines. Generally, if you've got enough data, you probably don't need the lines to see the trends, but if you feel like putting them in, then that's fine. And so you should end up with something that looks like this. Now don't forget to go back and label your axes, so that's very important when generating graphs. But here you should be able to see the stimulus-response relationship. Notice how for subthreshold stimuli, of course, the response is around 0. Then, as your stimulus is increased above the threshold for the most sensitive axons, you'll start to see a response. And that response will quickly get bigger and bigger as you increase the size of the stimulus. Now, eventually you'll reach the point where you've now stimulated virtually all of the axons in the nerve, and no further increase in stimulus strength will activate any further axons. And so therefore you see this plateauing up the top of your stimulus response. Now over on the next page, on page 8, there's a bunch of tutorial questions for you to work through, so I'll leave you to work through those and have a think about the results that we got for that experiment.